Essay 4.9 Normal Distribution. In this video, we will consider variables with a symmetrical bell-shaped distribution curves, and we call this a normal distribution. And normal distribution is most important distribution in statistics, but also in your curriculum. So let's talk about the normal distribution first. Although all normal distribution have the same general bell-shaped curve, so when I say bell-shaped curve, we are referring to curve that looks like this, the one that has a perfect bell-shaped curve. So, although all normal distribution have the same general bell-shaped curve, the exact location and shape of this curve is determined by the mean and the standard deviation. Okay. So if the x is normally distributed random variable with the mean and standard deviation, we use this notation here to identify the normal distribution. And then normal distribution is referring to a situation where we have a large set of the one variable data. So if you have a one variable data, that means you have most likely a normal distribution. Then, since we know that what is the normal distribution and then its notation, let's move on to each graph. So normal distribution is a continuous data. So showing probability in the bar chart doesn't work. So instead, a smooth line is required in the shape of the bell curve, and the total sum of the probability is still 1. However, for the normal distribution, we also say that the area under the curve is 1 or add up to 1. Okay, so if the mean decides the sector location, then the center of this curve is mean, and that the standard deviation decide how to spread out the data. So if you look at this graph here, for any population, or the area or probability we're is normally distributed. If it's normally distributed data, then the population is also normally distributed with the mean and the standard deviation. Means since the center is the mean, we can divide the area as following. So second one will be mean plus standard deviation. The other side we have exactly the same thing, but subtract standard deviation. Here we will have a mean plus 2 standard deviation, mean minus 2 standard deviation, and we will have mean plus 3 standard deviation, and we will have mean minus 3 standard deviation. So we can say that if we move one standard deviation away from mean, we have area about 34.13%. Same thing with the other side. If we subtract one standard deviation from mean, we have area about 34.13%. Okay. If we have 2 standard deviation away from mean, then we have about 13.59%. If we move 3 standard deviation away, we have about 2.15%. Okay. Similarly, if we subtract 2 standard deviation from the mean, then we have 13. That area between the 2 standard deviation and 1 standard deviation is 13.59. So the area between 3 standard deviation and 2 standard deviation is about 2.15%, and then the remaining part, the last part, 0.13% each side. Okay, so you must remember this spread of the data. Okay, then let's do an example number 1. So we have a sample of the cans of pears that was taken from the supermarket, and the contents of each can was weighted. The sample mean was 486, and the standard deviation is 6. So mean is 486, standard deviation is 6. question A, we need to find the proportion of the cans that weighted between 480 and 486. So we know that since we are talking about tens of pairs, this is one variable data, means we have to use the normal distribution. So if we just use the graph that we just talked about, this one here, we can say that since mean of the graph is 486, okay, then between 480 and 486 is same as area between mean and one standard deviation away. Okay, so means we have about 34.13% using the spread of data we just discussed. Then question B, we need to calculate the area that is more than 492. So same thing, using the spread of the data. We know the mean is happening at 486. Then 492 is actually one standard deviation away, right? So again, so mean and mean plus standard deviation. So we are referring to this part here, right? According to the spread of data we just discussed, we know that there are going to be 2 standard deviation and 3 standard deviation away, right? We will have here mean plus 2 standard deviation, mean plus 3 standard deviation, and the remaining, right? So we have to consider parts where the area between 1 standard deviation, 2 standard deviations, so 13.59%. Here will be 2.15%, and then here will be 0.13%. So the total percentage is 13.59 plus 2.15 plus 0.13, so it's about 15.87%. So you can see that expected cans can be expected to weigh more than 492 grams here. So we can say that 15.87% of the cans are expected to weigh more than 492 grams, right? So this is how you use the spread of the data to calculate the certain percentage, okay? Then let's look at example number 2. The chest measurement of the 18-year-old male soccer players are normally distributed with a mean 95 centimeter and the standard deviation 8 centimeter. So mean is 95, standard deviation is 8. So question A, from the group of 218-year-old male soccer player, how many would you expect to have a chest measurement between 87 and 111? So question A, again, let's start with the spread of the data. We know that the spread of data will look like this with the mean 95, right? Then 87 is actually value for mean minus standard deviation. So it's 95 minus 8 is equal to 87. So we are referring to this part here. And 111 is also one standard deviation away from the 95, or actually it's 2 standard deviation away. So one standard deviation is about 103, 2 standard deviation about 111, right? So this point here is mean plus 2 standard deviation. So we are referring to these 3 parts area under the graph. So for the question A, we know that we need to consider this part, which is 34.13%. Another part, 34.13%. And then the last part here is about 13.59%. So total area under the curve is same as 34.13 plus 34.13 plus 13.5%. So it's about 81.85%. So we have just calculate the area. However, we need to know how many. So we have to multiply the 81.85 to the 200. So we could expect that 81.85% times, or the of the 200 is about 164. Okay, so we can say that we can expect that about 164 of the soccer players to have a chest measurement between the 87 and 111 centimeter. Then question B, we need to find the value of the K such that approximately 16% of the chest measurement are below K centimeter. So using the spread of the data, we are not sure about the K value. However, after K, if this is K, everything below K is about 16%. Okay, then think about the spread of the data. We know that the lowest one is 0.13. We know the second one is 2.15, and the third one is 13.59%. So if you think about that, we have 0.13 here, 2.15, and then 13.59. So when you add all these three together, these add up to approximately 16%. So we know that is referring to 87, which is the K value is 87, because 87 is where the mean minus 1 standard deviation starts, right? So the answer is 87. Okay, then let's talk about how to calculate the normal distribution using technology. Just all other statistical concepts that we studied in IB Math AA curriculum, we can also quickly calculate the normal distribution using GDC. So if you tell your GDC the mean and standard deviation, then you can ask what percentage of the population lies between certain value. And this is the same as asking for the probability of somebody chosen at random being in the interval, or the area under the curve between the interval. And this process is called normal CDF on your GDC. Okay, so normal CDF, we always have to use 10 to 99 if the upper boundary is not given, and use minus 10 to 99 if the lower boundary is not given. So if you have a TI-84 calculator, you can use the following keystroke to use the normal CDF. So we first have to press second and press the button DISTR, distill, and go to second one in the command list. So number 2, normal CDF, and after that enter your mean, standard deviation, your upper boundary or UB, and your lower boundary LB, and hit enter. Then you can calculate your probability. If you have a TI Aspire calculator, what you can do is you can first click menu and hit 5 prop and hit 5 distribution, and then you can click on 2 normal CDF, and you can enter your information. So mean, standard deviation, upper boundary, and lower boundary. Okay, so this is the keystrokes for the TI Aspire and TI-84 Plus calculator. Then let's try to use this keystroke with actual questions. So if you look at number 3, we have the variable x which is normally distributed with the mean 40 and standard deviation 10. So this is normal distribution, and mean value is 40 and standard deviation is 10. Then for the question A, we have to calculate the probability that x value is greater than 37 or less than 48. So 37 will be your lower boundary, 48 will be your upper boundary. So using your GDC, if you have TI Inspire, you can do second, this, and then 2 normal CDF, and then after that you have to enter your information, right? So you plug in mean equals to 40, standard deviation equal to 10, lower boundary equals to 37, upper boundary equals to 48. Then you hit enter, then you'll be getting your probability value approximately equals to 0.406. Then question B, if you have probability that x value is greater than 45, so in this case, since x value is greater than 45, 45 is your lower boundary and you're missing your upper boundary. So in that case, you will be using 10 to 99 as your upper boundary, okay? So we do mean value equals to 40, standard deviation equals to 10, your lower boundary equals to 45, but your upper boundary is equal to 10 to 99, okay? We use 10 to 99 as your upper boundary value or negative 10 to 99 as your lower boundary value for your GDC, because that is the largest number and the lowest number the GDC can recognize, okay? Then you get question B, the probability that x is greater than 45 as 0.309. Then question C, we need to calculate the probability that x value is less than 26. So we know that the x value has to be less than 26. That means this is your upper boundary, okay? Then we do mean equals to 40, standard deviation 10. Your lower boundary in this case is not given, so we're going to do minus 10 to 99, and your upper boundary equals to 26. Then you get your probability value of 0.081. Okay? Then let's do example number 4. You can stop the video and try this question and then play again if you want. But example number 4, we need to consider the height of the people. Mean is equal to 181 and standard deviation is equal to 4. We need to find the probability of a random person being over 186. So we need to find the probability that random person X is over 186, right? And your mean value is 181. Standard deviation is 4. That means 186 is your lower boundary. Upper boundary is 10 to 99 because it's missing. So we can do normal CDF with your with your GDC. So we can do normal CDF with your GDC. Then we can set mean is equal to 181. Standard deviation is 4. Lower boundary equals 186. Upper boundary equals to 10 to 99. And hit enter. Then you should be getting your probability that x is greater than 186 as 0.106. Okay, then now let's talk about the cases where we have to find the variable x. Okay, so in the previous question, you always had your x value. I mean, the range of the x value was given like this, right? Such as like p of x is less than 26 from the question number 3, and then it's approximately equals to 0.081, right? So in this case, you use the variable and its range to find the area. However, sometimes this is not the case, okay? So in those cases where you have to find the variable 26, for example here, you have to use the inverse norm to do it, okay? So the keystroke to use the inverse norm is same for the TI Inspire and TI 84, but you still do second. You go DISTR distribution, and you click on number 3, inverse norm. Okay, so if you look at case here, we have to consider a case of population of the petal-baked crabs where the length of the shell x millimeter is normally distributed with a mean 70 millimeter and standard deviation 10 millimeter. So mean is equal to 70, standard deviation is 10. We have a marine science class students wants to protect the population by allowing only largest 5% of the crops to be harvested. They therefore want to know the what length of corresponds to the 95th percentile of the crabs, where its length is less than or equal to the K value, and the area is equal to 0.95. So in cases like this, we need to find this K value with the using information, mean, standard deviation, and area, okay, value of the area. So let's look at example 5. So we are now trying to find. So when you look at example number 5, this case is written more in the question format. So we have a population of the petal-baked crabs that has a shell length of x millimeter, and x is normally distributed with the mean 70 and standard deviation 10. And we need to find the K value where x is less than K and gives the area 0.95. Okay. So in order to do this, you're going to click on second distribution and 3 inverse norm, and you're going to plug in the values such as area equals 0.95, mean equals to 70, standard deviation 10. And when you do this with the tail setting as left, you will get K value approximately 86.45. Then let's talk about why we are setting the tail as a left, not as a center or the right. Okay. So if you look at this probability here, we know that this is normally distributed data, and the mean is happening here, and we are not sure about the K value, but we are trying to find the variables that is less than K, right? And then this part is about 95%, right? So you can see that the area that we are looking for is located on the left-hand side of that K value. So that's the reason why we say the tail is left. Okay, so however, a GDC can also find the upper boundary given the area / probability is given and also with the mean and standard deviation. So if you are asked about lower bound, you always must do the 1 minus area to effectively turn it into the upper bound. So means if you look at example 6, we need to consider the height of the mean equals 181 centimeter and standard deviation is 4 centimeter. We need to find the K for which P of X is greater than K and is equal to 0.70, right? So P of X that is greater than K, and the probability is equal to 0.70. So means using the normally distribution graph, using the graph, we can say that, okay, so this is the normally distributed data, and we can say that we are not sure about where the K is located. However, since X is greater than K, the 0.70 refers to the ones on the right hand side. Okay, if you're using TI-84 calculator, this you can still choose the right and calculate your missing K value. However, that's not the case for all the calculator. So what you need to do is you always first have to calculate the left hand side of your K value. So we know that this part is 0.70, that means this part is 0.30, right? Because the area under the curve for this case is always add up to 1. So we can calculate the 0.30 by subtracting 0.70 from 1, right? And then using the inverse norm, we can calculate the probability that x is less than k and the area equals to 0.30 in that case. So using the inverse norm, we can set area equals to 0.30, mean equals to 181, standard deviation equal to 4, and you have to set the tail as left. Then you get x variable approximately equal to 179. Then we can say that since this k here is same as this k, we can still say that k value is equal to 179. So remember this, you can still choose the right and calculate your k value. However, that depends on calculator, right? Not all the calculator does that. So first figure out where that x value greater than k is located, the area of the x value greater than k is located, and find the area that has the x value less than k, and do the left tail and calculate your k value. Okay.